Okay. The next thing I want to bring into it is the concept of inefficiency. Okay? The concept of inefficiency. Yes? Okay. So let's say, you know as well as I do that if I took this particular inclined plane, I took a board, made an inclined plane, you see that that's rough, correct? That's rough. If I slide something against this, that's going to be, I can feel the friction. Yes? You believe me? I can feel the friction. I mean, it's not terrible, but I can feel it. Okay? If I took this is very heavy, very dense. You can hear it. Can you hear it? You can hear the friction. Yes? Yes? So, we know that if I lifted this box here, I'm going to say 1,000 newtons times 1 meter equals 1,000 joules, based on our last example, correct? The height of where I want to get it to is 1 meter. Okay? So now I'm going to use an inclined plane that's 10 meters long. And I'm going to slide the box. Starting right here. And I'm going to put in some force. And you know there's friction, so let's just make up numbers. Ideally, I should be applying 100 newtons. Would you say that's true, right? 100 newtons. Ideally, is 100 newtons. It's going to be 1,000 joules. Ideally, because they're equal, correct? Just like last example. So 1,000 divided by 10 meters is 100 newtons. But we know that I'm going to have to apply a little bit more. I'm not going to have to apply 1,000 newtons to get that up the inclined plane, but I will have to apply, let's say, 120 newtons. Is that okay? So I'm going to have to apply 120 newtons. That's my application. Okay? Yes? Okay. So let's now talk about mechanical advantage. You have two types of mechanical advantage. AMA and IMA. Write this down. AMA stands for actual mechanical advantage. That's real mechanical advantage. That includes friction, wasted energy, the whole thing. It's called AMA, actual mechanical advantage. Actual mechanical advantage. Actual mechanical advantage. Okay? As opposed to IMA, which is ideal mechanical advantage. Yes? You with me? Okay. Yeah. Actual mechanical advantage First of all, their whole number or their ratios greater than 1. Write that down. They're always ratios greater than 1. So it's always the larger over the smaller. So what's larger? My FO or my FI? What's larger? FO or FI in this particular case? What's larger? Isis? I know that my FO is 1,000 newtons. Correct? Yes? I'm going to have to apply 120 newtons. That's my FO. My FI, sorry. This equals FI. What's larger, FO or FI? What is it? No, well, I mean, you're not sure? You don't know what number's greater? 120 or 1,000? Really? Are you making this into some complex scenario? FO is larger, correct? So my actual mechanical advantage will be FO divided by FI. Okay? And it's going to be 1,000 newtons divided by 120 newtons. What is 1,000 divided by 120? They need a calculator. It's okay. What is it? 803? Really? 1,000 divided by 120 is 803?
That's not what I said. I said 8.33.
8.33? Okay. I thought you said 803. I mean, you talk like you have a sock, you know. I mean, I know. So okay. They're very good with masks. I want you to know that. Very good. 8.3. Is that what it is? So it's going to be, I'm going to erase this. Is that okay? It's going to be 8.3. What should it be? What should it be? If it were ideal, what would it be? It would be 10, right? Because it would be 1,000 over 100, correct? Yes? But it's not. It's 8.3. It should be what? It should be 10, but it's 8.3. Okay. So how do you get the ideal? The amount of force that I have to apply, Fi, is going to vary, correct? You get that now? Apoorva, do you understand that? Misa, you with me? Yeah? But will the distance change? No, the distance is constant because for that machine, distance doesn't take into account friction, it's just distance. And so for the ideal mechanical advantage, larger number over smaller number, is going to be di over do, which is 100 over 10. Right? And that's going to be equal to 10. So the ideal mechanical advantage will work with distances. Notice something. There are no unit labels for mechanical advantage. They cancel. There are no unit labels for mechanical advantage. So you see how we could use mechanical advantage to understand something about the efficiency. What would the efficiency be? Anybody know? What would the efficiency be? There's an equation on your sheet that talks about efficiency. What is it?
It's AMA.
Yeah, you can get it in two ways. Excellent. Romana, what's the first way? So percent, let's just say, let's not use percentages. Let's say efficiency will equal, remember, efficiency is going to be a smaller number over a larger number, right? It's a decimal, right? The most efficient would be 1. Percent efficiency would be times 100, so 1 times 100 is 100%. So it's going to be your smaller number, your AMA, over your IMA. In this case, it's going to be 0.83 will be the efficiency of this machine, correct? Yes or no? You're all right with that? You can also get it by saying this. What is my work input? What's my work input? Work input. FIDI. So 10 times 120 would be what? What's 10 times 120? $1,200, and my work output is here, would be 1,000, right? So you can get it by saying will equal the smaller one, 1,000. Is that correct? It's on your sheet. What would it be? What's smaller, 1,000 or 1,200? Is this right? This isn't even right. Is it? What did we say? Is that right? How much force am I going to use here? Did I say 120? I did. Okay, so that's right. So 10 times 120 is 1,020. So what's smaller is going to be the work input is larger, so it's going to be work output over work input is 1,000 divided by 1,200. What does that equal? What's 1,000 divided by 1,200? No, oh, you refuse. You refuse. You're angry with me for not understanding what you said.
Yes, I
Okay. What do you got? So you still needed to calculate. Okay. 0.83. Yeah, either way you do it for this particular example. So we did FI, FO, DI, DO. Work input, work output. AMA, IMA, percent efficiency. You okay with all that? Yes or no? Questions? Okay.